following is a introduction to using Python and the IPython Notebook. Python is a programming language that we can use in lots of different ways. Here I'll show you a quick way. Basically, we write commands and then we need to execute those commands. And we write commands into a text file and then we execute them using the Python interpreter. So one way we can do this is just to create a text file. Maybe I'll call it test.py. This is just a blank file right now, test.py. The .py at the end just instructs the computer that the code that it contains is Python code. We can open it in our favorite text editor. And it's just a blank file. And then we would write our Python code. So as a really simple example, we can name a variable a equals 5.5, b equals 10.0, and maybe c equals a times b, and then we can print something to the screen. Print a times, well, hi there, a times b equals, and then we'll output the value c, and then we can save that. Now our text file is, and we can run this code using Python. If we're at a command line, like this white screen here, we can type python test.py and it runs our code. Hi there, a times b equals 55, like we expect. Or we can go in and type to a Python editor like Python, type it at the command screen, and then we get an interactive prompt here where we can run that test.py file, exec file test.py with quotes around it. It runs the content. So all the commands that are in test.py get executed and those get dumped to the screen. In interactive mode, like we are now, we can also set our own variables like a equals 5.6, b equals 10, c equals a times b, and we can output c, we can print to the screen c. Any commands that we can enter in Python, we can just do it locally, and so we can use this Python terminal as a calculator, if you will. Normally, however, we write programs that are long enough that we want to write all the commands in a text file like we did with test.py. If you're editing these, you want to make sure you use a text editor. Don't use Microsoft Word. Use something more like Notepad in Windows or some other language that won't do anything to the text besides giving you the raw text in the file. So that's a simple way to use the Python editor if you're at a command line. Almost every Python distribution comes with a program called idle. And if we want, we can open this file, test.py. Let's see. We can open it with Xcode. It wants to open it with Xcode here. Quit that. We don't need Xcode. We can open it with idle. Idle is a program that will basically operate as an interface to Python. Maybe. Let's just try running it directly. Idle. And so this will bring up a little shell here again with this triple prompt. We can go up to File, Open, and open up our test.py, and then we can see the text of our program that we wrote. And if we want, we can even just run it from within this text window. We can go run the module, and it executes the code and outputs in this little Python shell. There's lots of different Python editors that are available. A really popular integrated development environment is called Spider. And Spider is a nice program for developing Python software. We can see our text window here, test.py, and this has applications for running the code and gives you lots of options. You can debug the code. It helps you with command substitution and other nice features. The program that we'll use in our class is going to be the IPython Notebook, which is a particularly nice environment for creating and working with Python code, especially for the kinds of programming that we'll do in our class and for homework size problems. One thing I should mention is to get Python on your computer, Python consists of many different packages and different software applications, and if you want everything all in one install, the place to go is Anaconda. So if you go to your web browser and type in Anaconda Python, then the first links that will come up are this download Anaconda Python distribution. It works on Mac and Windows and Linux, and you can just download a single executable and install all of the packages, the IPython Notebook, IPython, it'll have idle with it, it'll have Spider, and it'll have all the scientific Python libraries, including plotting capabilities, that we'll be using in our class. So go ahead and download and install that. In our classroom lab, it's already installed, and we would go ahead and go from the Start menu and then click on the IPython Notebook to start that up. I'm going to do that here from the command line, IPython Notebook. And the IPython Notebook, the editor, actually runs in your web browser. So you're going to save your file inside your web browser and do all the editing inside the web browser. The first thing you get is just a list that shows what's in the current working folder. So I'm going to click on New Notebook to give me a new Python notebook, and then we can name it anything we want. So I'm going to call this test. Okay, and this one names the file IPynb, test.ipynb, as in IPython Notebook. Now, what we see immediately is a standard set of menus. We can see some icons for saving files, drop-down box for code, etc., toolbar. This is where we would enter our text here in this in box. So if we wanted to, we could type a equals 5.5 as a variable, b equals 6, c equals a times b, and then if we want, we can print maybe hi there, comma c. And then this is what's called a code cell, and we can execute all the code that appears in this cell. So one way to do that is to go hit this play button, and it runs the code and then executes it below. You can see what was output. Or as a shortcut, you can hit Shift Enter, and it'll do the same thing. So you can have as many of these code cells as you want, and it's convenient to just break up your code into pieces using the code cells. Now these code cells don't have to be code, they can have different types, and we can decide what kind of type we want them to be. So we can have a code cell like we have, or Markdown, or raw, or different kinds of headings. These commands here we can insert a cell above. Maybe we'll change the type here to be heading 1, and we can name our worksheet like test IPython Notebook, like so, and then I'll hit Shift Enter, and we can see that it looks like a pretty heading. We can also, let's enter another one, insert another cell below this one, and let's change this to a markdown. If I want to just write regular kinds of text, I'll do that in a markdown cell. So here is a basic description of this notebook. This is where I would write the problem statement for a homework problem, or describe what I am trying to do. Okay, and we can enter that and it just shows up as formatted text. The markdown cells are really nice. You can do all kinds of formatting. If you want to have bold text, for instance, you can put 2 stars. This text will be bold, double star to end that, and this text is not. Okay, and you can format it. Single stars will make it italics, like this is italic, end star. And so you can see basic formatting. You can do other things like making a bulleted list, and you can start that. Maybe you want a numbered list. You do that with 1. This is a numbered list, and 2, here is the next item. You can do numbered lists with bullet points. That would be a star space. Here is item 1, item 2. You can tab in to do sub bullet, another sub bullet, and maybe another sub. Whoops, tab that in again. Let's just tab it in, sub, sub. So you can see, and it automatically formats these different items. So the markdown is a nice way to do this. You can insert hyperlinks if you want. An easy way to put a hyperlink would be like, here is a link to Google in brackets, and then after that you put in parentheses the web link, google.com, and then we have the link here. Oops, I think I didn't do that right. Let's try that the other way. At any rate, those are markdown cell. You can do all kinds of nice formatting with markdown. It'll also take formatted equations, and we'll talk about this a little bit later, but if you want to format an equation, here is a formatted equation in line with the text, and then a $sign, and then you can put your equation like a equals, I don't know, sine x, and it'll format the text for you as an equation. You can also do one that's not inline. So inline, a equals, and the integral would be /int f of x dx. That'll go inline. If you want one that goes centered, you can go here is a centered equation. Just use a $sign, and then you can type like int underscore a hat b f of x times, maybe we'll do a fraction, /frac x minus 1, and the numerator is the first set of braces, the denominator is the second set of braces, x squared dx. Oops, don't forget to end the $signs. And you can get a nice formatted equation in your notebook. So this can be a nice way to create equations and describe what it is that you're trying to do. So those are different kinds of cells, heading cells, markdown cells, code cells, and then you can move the cells around. So if I want to move the cell up, I can change its location in the list. And if I want to rerun these, I type Shift-Enter to rerun the code. Now, we've already made use of variables in Python. Variables are easy to do. You don't have to do anything other than set something to a variable name, like a equals 6. That's a variable. You can name variables pretty much anything you want, but you should always start them with a letter, like my underscore var3 equals 2.2. So that created a variable named my underscore var3 equals 2.2. And that's an easy way to name a variable. Basically, it just stores the value of 2.2 in the variable that you name. And then you can refer to those as you want. So c equals, like a equals c times my underscore var3, and we can output that, and it'll output what the value of a is. If you don't put anything, just put a by itself. When it executes it, it'll just output the value to the screen here. Otherwise, you can type print a, and it'll do kind of the same thing. It's important to note that variables don't always do what you want them to do. So the standard operations are going to be like times, oops, the standard operations will be, let's do markdown cell, like multiplication, division, addition, subtraction. But you can also do powers like a, if you want a to the 5th power, you don't type a up 5 like you would in Excel. You type a star star 5. So if we want to give an example, we can do like a star star 5. Enter, and it gives us the power. Star star means raised to the power. The usual use of parentheses is used, so a, if we use parentheses, a plus b star star 2.0, then it'll square the sum of a plus b. So those are pretty standard operations. We can write comments in the code. So suppose we want to make a variable and add a comment, like what this is. So this would be like, if you add a comment, comment lines always begin with a pound sign. And you can, wherever the pound sign is, anything that comes after it is a comment. So here I could say what this is, like the inlet temperature in Kelvin. Put the units in there. And then those comments will be ignored as code, so they're just a way to annotate what you're doing. You can also do comments as beginning of a line, so there's just an easy way to demarcate the different sections of the code. And so comments are really useful. You'll want to use those liberally. Python is a little bit different than some languages in that you have to be careful about indentation. If I make a variable like a equals 5, and then I indent another variable like b equals 6, and then try to run that, it complains because it expects everything to be lined up, and it enforces that. So we need to make sure that all of our variables are indented. And the indentation will be used when we do when we do things like make functions and for loops and if statements and such. But as a preview, we can show like if a is greater than 2.0, then we can print a was greater than 2.0. Otherwise, else, print a was less than 2.0. Okay, and then maybe we're done. And it looks like I made a mistake. You need to put a colon after this. And I forgot. You can see one of the nice things about Python is it will tell you as you go if you made an error. So here I forgot the parentheses on the end. And else, I need a little semicolon there, and then it works great. So we'll learn more about the syntax of using if statements later. But here you can see that you need to have it indented. If I don't indent it, then it will complain, expected an indented block. So Python actually requires this, unlike most other languages. But it's not a big deal because you should do this anyway. So that's a comment about indentation. We'll talk some more about the different parts of a program. The main parts are going to be things like variables, conditional statements like an if block that we just saw, loops where we can do operations on the code multiple times, declaring functions that split off code so that we can reuse different parts of a program, and also importing different libraries from different places in the code. We're going to use NumPy extensively in this class. So if you want to use libraries that are in NumPy, we need to explicitly import those. To do that, we would type import NumPy as np. Enter. Now we have access to all the NumPy functions. To access those functions like sines and cosines, etc., we can type np.sine 2.2, and it will output the value for us. Or we can make arrays this way. We can do all kinds of different functions if we have access to the NumPy library. But in order to use all those functions, we need to import them. And the syntax is import NumPy as NP. We'll talk later about different import syntaxes that are available, but this is the most useful one. And then we would access those functions like np.sign, in other words, the NumPy function sign, and then the argument of the function. So there's many other things that we can do with the notebook. One of the other packages that we'll use extensively, I guess we'll just include these, would be matplotlib. Well, for the notebook we need to type %matplotlib inline, and then import matplotlib.pyplot as plt. And if we do that, then we can have access to the plotting features within the notebook. These comments here are things that will basically show up in every notebook that you create. So you'll want to make a reference to these commands somewhere that you can copy and paste them in your code. And we'll normally put those at the very top of the program, somewhere up at the beginning, maybe where our code starts. And as soon as we've entered those, then we can start to, let's delete some of these old commands here, then we can start to use them. So later on we'll see how to make an array, but as an example we can make x equals np.linspace 0 to 10 with 100 points. This will create 100 data points that vary between 0 and 10 with a uniform spacing. And we can make y maybe equals x squared. Now we have x and y, and we can plot those with plt.plot x comma y, and it will create a plot of the data for us, and then we can format it. So this is a nice way to generate both the code and the output and the formatting all in one place. And we'll use this quite a lot as we learn programming with Python later on through the course.